Compound interest. Suppose we deposit 1,000 in an account paying 4% interest per year. How much money we will have after 3 years? So let's see. After first year, we had this 1,000 that we deposit plus the interest paid by the company, by the bank. So interest is 4%, so we need to change 4% to decimal and multiply this 1,000. So we will have 1,000 that we deposit, and this is the interest. If we multiply 1,000 times 0.04, that's gonna be equal $40. So if we add $40 to 1,000, we will have $1,040. Now, out of this, as I had this one, I can factor 1,000 out, and what we will have left from the first one, we will have 1 if 1,000 is in front. From the second one, it would be 1,000. 1,000 is in front, and 4% is left. So if we go back and multiply this out, we will have exactly this amount. Now, on the second year, we will have interest paid from the balance. So we have $1,040 plus interest. But now the interest is not calculated from the 1,000, but the interest is calculated from my beginning balance. So we will have 1,040 plus 1,040 times the interest. So if we multiply the 4% in decimal 0.04 times 1,040 and add the original amount, then we should get this number. And as before, from this equation, I can factor from this equation 1,040 right here, and what would be left? From those two, I would factor 1,040. So what is left? From the first one would be 1. From the second one would be 4%, right? So I would have 1 plus 4%. So this is exactly right here. But now 1,040, this is this amount. 1,040 is equal to that. So I can substitute this for this part. And this part is equivalent to what we had 1,000 and in the factor form. So instead of this 1,004, we substitute this part for this 1,004. So basically this part is substituted for this. So what we have, now we have 1,000 plus times 1 plus 4%, and then we have from this account 1 plus 4%. So if I have two the same brackets, that means it's squared, because we know that a times a is equal to a square, or bracket times bracket would be the bracket square. After the third year, so the third year we start with the balance from the second year. So this amount we have at the beginning of the year plus interest, and that 4% interest is calculated on the original balance. So we can proceed exactly the same. We can factor this number out, 1,400. So this would be this, or if we calculate this, we would have this amount. Or we can keep substituting. So this amount, which is the second year, is equivalent to this amount. So if I substitute this for here, I'm going to have 1,000 plus times 1 plus 4% to the power 2 times this one more bracket. So this is to the power, if you have square and one more, this gonna give me to the power 3. So let's see, let's notice the pattern. Second year, we had this 1 plus 4% to the power 2. Third year, we had this 1 plus 4% to the power 3. And we can proceed until we get to the nth year. If we have nth year, according to the pattern, we would have 1000 times 1 plus 4% to the power n for the nth year. So in general, this gives me the formula for the compounding interest. Compounding interest means that my interest, what I earned, this $40, also generates me more money, because now the second year interest is calculated from this amount, from this original amount, and the interest from the first year. So the interest makes even more money for us. So this is the simplified compound interest formula, that the final amount is equal to the original amount what we deposit, call it P for principal. Then we would have 1 plus percentage, and then how many years T is in years. Now, if the interest is compounded not once a year, but twice a year or 3 times a year, we would need to add more. We would need to add more and divide this interest into how many times is calculated. So this is the compounding interest formula. A is my final amount, P is the principal, and then we would have 1 plus R over N. So the interest rate is divided, if we calculate interest twice a year, 3 times a year, and this would be to the power how many years and how many times per year. If we calculate twice per year for 4 years, then we're gonna have 2 times 4, which gonna be 8 times calculated interest. So P is called the principal, or the initial amount of money that we deposit or invested. R is the interest rate per year, and interest rate needs to be in percentage. And N is the number of times the interest is calculated per year. If we calculate twice per year, 3 times per year, and so on. T is the number of years. So A is called future value, and P is called present value. Now, interest can be compounded or calculated annually, that means once a year, semi-annually, which means twice a year, quarterly, that would be 4 times a year, monthly, 12 times a year, or daily would be 365 times per year. So we have example. An investment of 4,000 is earning 6% interest compounded semi-annually. Find the future value of the investment after 8 years. So we had this formula for compounding interest. Now we need to list, I think the most beneficial is to list all the letters what we have and what we have it. So we have A, we have P, we have R, we have N, and we have T. A, P, R, N, and T. So A is the final amount, that's what we are looking for. P is the initial amount we deposit, so it's 4,000. So we deposit 4,000. R is the interest rate per year, so 6%, we need to change it. 6%, how do we change to decimal? We divide 6 divided by 100, because percent means out of 100, which is 0.06. Now N is how many times per year? Semi-annually means twice per year, so N is 2. T is for how many years? We have for 8 years. So T is 8. So we're going to calculate using the formula. A is equal to P 1 plus R over N to the power NT. So A is equal to 4,000, 1 plus 0.06 over 2 to the power 2 times 8. So this is equal to 4,000. If I divide this 0.06 divided by 2 gives me 0.03, and I add 1, so it would be 1.003 to the power, and 2 times 8 is 16. So then we can type everything on calculator, and we're getting 6,418.82536 or 26, something like this. So we need to always final answer round to 2 decimal places to the nearest cents. So to 2 decimal places, we look at the next digit is 5 or more, so we round it up this number 1, increase it by 1. So 6,418 and 83 cents. This is the amount if we deposit to the account 4,000 and we do not add additional money. This is the amount after 8 years we will have 6,000 if the percentage rate is 6%. So this is part A. This is part A. Now we can do part B. For part B, exactly the same. List what is given, P, R, N, and T. A, we need to find P is the principal initial amount. It didn't change. We're still depositing 4,000. Interest rate is still the same, 6%, which is 0.06. Now, how many times per year? Quarterly means 4 times per year. And T is how many years? We have 8 years. The same formula, A is equal to P 1 plus R over N to the power N times T. So A is equal to 4,000 to the power 1 plus 0.06 divided by 4 to the power 4 times 8. So this is equal to 4,000. Now if I divide 0.06 divided by 4 is 0.015 plus 1. So that would give me 1.015 to the power, and 4 times 8 is 32. And this we can type everything on calculator, and I'm getting 4,441.29729 and so on. As before, we rounded to the nearest cents. So I'm looking for the next number is more than 5. I need to increase this by 1. So this would be 10. So that means we had 30 cents. So the final amount is 6,441 and 30 cents. Example 2. Find the principal present value of an investment that gives 5,000 after 6 years with an interest of 4% compounded annually or compounded monthly. So now we need to find present value, that means the P. As before, I suggest part A, that we list all the letters A, P, R, N, and T. So now we have A because that gives us the final amount, which is 5,000. So final amount is 5,000. Present value or principal we need to find. Interest rate is 4%. Change to decimal. 4% divide by 100. So it's 0.04. N is how many times per year. If we have annually, that means we calculate once per year. And times is how many years, compounded for 6 years. So T is 6. And then we use the formula that A is equal to P times 1 plus R over N to the power NT. So we have 5,000 is equal to P times 1 plus 0.04 divided by 1, 1 times 6. 0.04 divided by 1 is 0.04. So we have 5,000 is equal to P 1 plus 0.4 to the power 6. So we can perform this 1.04 to the power 6. So we would have 5,000 is equal to P times, and I'm getting 1.265,319. So then to solve it for P, we would need to divide by 1.265,319 divided by 1.265,319, and this cancel out. So my principal is P is equal to 3,951 and 57 cents. And this is for part A. For part B, I suggest exactly the same. List what is A, what is P, what is R, what is N, and what is T. A is still 5,000. P is what we need to find. R is 4%, which is 0.04. N is how many times per year. This time we have 12 monthly. How many months in a year is 12. So N is 12. And T is how many years? And we have 6 years. So now we have again the formula A is equal to P 1 plus R over N to the power NT. So we have 5,000 is equal to P 1 plus 0.04 over 12 to the power 12 times 6. So this is equal to 5,000 is equal to P, and when I divide 0.04 divided by 12, I'm getting 0.0333. So we will have it plus 1 would be 1.003333 to the power 6 times 12 is 72. So first perform this power. Usually keep several decimal, maybe 6 decimal, until final answer. Then the answer is more accurate. So then we have 5,000 is equal P times, and I'm getting 1.270741879. So then to solve it, we would divide 1.270741879 divide, usually either use the power answer key 1.270741879. This whole stuff cancel out, and then my P is equal to 3,934 and 71 cents. Example 3. What rate of interest compounded annually is required to double an investment in 5 years? So now we're going to list again what we have: A, P, R, N, and T. So let's fill it up what we know. 5 years would be my time. So 5 is T is equal to 5. Compounded annually, how many times per year? It's just 1 time per year. Interest rate, what is the interest rate? So we need to find the interest rate, and that's pretty much what we have. But now it says what rate of interest compounded annually is required to double an investment. So that means I can choose for P any value I want, and then for A I would double that investment. And it doesn't matter which value you choose, as long as you double and later you would have exactly the same answer. So let's choose 100 for investment, and double it would be 2,000. So if we it would be 200. If I have 100, double it would be 200. Write the formula P 1 plus R over N to the power NT. Substitute 200 is equal to 100. We would have 1 plus R we need to find over 1. And then we have 1 times 5. So we have 200 is equal to 100, 1 plus R to the power 5. So first step, we need to divide by this 100. So we need to divide by this number. So first we're gonna both sides divide by 100, divide by 100. So this is gonna be divided. So we have 2 is equal to 1 plus R to the power 5. And now, so at this point, actually, you should notice, like, whatever, if you choose 1,000, here you would have 2,000. And then you divide by 1,000, so you still should end up with 2. If you choose, for example, 200, you double it would be 400. So you would divide 400 by 200, it would still end up 2. So at this point, you should have exactly the same equation, no matter what P you choose and what number did you double. So now to solve it for R, we need to get rid of the power 5. So we take the fifth root. Take the fifth root of both sides. Take the fifth root of both sides. Then fifth root and the power 5 cancel out. So we have fifth root of 2 is equal to 1 plus R. Type on calculator fifth root or write it as an exponent. Fifth root can be written 2 to the power 1/5 and use the power button as well. You can use either power button or the fifth root button. X root probably is or nth root on a calculator. When you use this 1/5 power button, you need to make sure that you type it the power 1 divided by 5 in parentheses, 2 to the power 1 divided by 5 in parentheses. When I type on calculator 2 to the power 1/5, I'm getting number 1.148698355 is equal 1 plus R. Then to solve it for R, we subtract 1, we subtract 1. and we having 0.14868355 is equal my R. To write it as a percentage, we would multiply times 100 to write as a percentage. So we have that my R is equal to 14.868355%. So round it to 1 or 2 decimal. To round it to 2 decimal, look at the next number. So we need to move it up by 1. So the R is equal to 14.87%. Now, if the interest is compounded more often, then we can call it more than daily, more than hourly. Then we can compound it, we so call it continuously. Continuously, that means the exponent would gonna approach e. So the formula would be A is equal to P e to the power R times t. If we remember that the letter E was approximately 2.7 something, right? This is like letter pi that we have it. So then the interest is compounded continuously. So A is the final amount, P is the principal or the initial amount, R is the interest rate, and T is the number of years. In order to use this formula, the question needs to say continuously, interest compounded continuously. If we don't have this word continuously, we're using the previous formula. Example 4. An initial investment of 4,000 earns 7% interest compounded continuously. What will the investment be worth in 10 years? As before, from this formula, let's list the letters A, P, R, and T. So A, P, R, and T. A is my final amount, so this is what I'm looking for. P is the initial amount, in that case it's 4,000. So we have 4,000. R is interest rate, we have 7%. Write it in decimal, divide 7 divided by 100, 7%. 7 divided by 100 is 0.07. And T is number of years, so we have 10 years. Then we write the formula A is equal P e to the power RT. We substitute 4,000. E to the power R is 0.07 times 10. 0.07 times 10 is 0.7. So we have 4,000 e to the power 0.7. On your calculator, look for the button e to the x. Probably second function you need to use to type e to the x. And if we do it, then we have it that the amount is 4,000 times 2.013752. And when I multiply this times 4,000, I'm getting that the final amount is 8,055.01 cents. If we use, I want to emphasize that the approximation makes different numbers. If we use for E 2.7 and you type on calculator 2.7 to the power 0.7, you're getting the number 2.7 to the power 0.7, then we're getting the number 2.00426. And if I multiply this times 4,000, then if I multiply this times 4,000 times 4,000, I would get amount that is 8,017 and 5 cents. So we can see that the approximation is a little bit different. That's why we try to keep it couple decimal. Usually when you calculate, keep around 6 decimal, and then at the very end round it to the nearest cents. Example 5. Find the principal needed now to get 1,200 after 2.5 years at 6% compounded interest continuously. Interest compounded continuously. So we're using the compounded interest, continuous compounded interest. So as before listed, what is A, what is P, what is R, and what is T. Now find the principal, so we need to find P. My amount is the final amount is 1,200. So this one is 1,200. Interest rate R is 6%. So we have 6%. Write it as decimal. 6 divided by 100 is 0.06. And time is 2.5 years. So let's write it 2.5 years. Write down the formula. A is equal P e to the power RT. So we have 1,200 is equal to P times e to the power 0.06 times 2.5. And 0.06 times 2.5 is 0.15. So we have 1,200 is equal P to the power e to 0.15. Now use the exponent button. If perform this e to the power 0.15. So we have 1,200 is equal P. When I multiply this out, I'm getting 1.16183. So then to isolate for P, we would divide 1.16183, divide 1.16183. This and this cancel out. So we have P is equal to 1,032 and 85 cents. So the principal should be 1,032 and 85 cents. Example 6. If Peter has 500 to invest at 6% per annum compounded monthly, how long will it be before he has 800? If the interest is compounded continuously, how long it will be? For part A, the interest is compounded monthly. We would use the compounding interest formula. For part B, the interest is compounded continuously. We would use the compounding interest, continuous compounding interest. So for part A, let's list what is A, what is P, what is R, what is N, what is T. A is the final amount. Final amount is 800. So we have 800. P is the initial amount. Initial amount is 500. R is the annual interest rate. So we have 6% per annum, means annually interest rate is 6%. Change it to decimal, divide by 100. 6 divided by 100 is 0.06. N is how many times per year is compounded the interest. Monthly means 12 times per year. And then we have how many years? How long will it take? So we need to find this T. That's the question. So we have the A equal P1 plus R over N to the power NT. So we have 800 is equal to 500, 1 plus 0.06 divided by 12 to the power 12 times T. So first we would divide 0.06 divided by 12. That gives me 0.005 and then add that one. So what we have is 800 is equal to 500, 1.005 to the power 12t. Now to solve it for t, first we would divide by 500, divide by 500, 800 divided by 500 is 1.6, is equal to 1.005 to the power 12t. If my t is in the exponent, to bring it t down, we need to use logs of both sides. Takes log of both sides. That would be the next step. So we have log of 1.6 is equal to log of 1.005 to the power 12t. Now by the property of log, this exponent can go in front. So we have that this exponent can go in front by the properties of log. So we have log 1.6 is equal 12t log 1.005, and then we can divide one by one or all together. Divide by log 1.005, divide by log 1.005. This log and this log cancel out. Use your calculator. I'm getting, use your calculator, log 1.6 divided by log 1.005. I'm getting 94.23553232 is equal to 12t. So then we would divide by 12 to solve it for t. Maybe use answer key and what, so t, in that case t is equal to 7.85 years. This is for my part A. For part B, use exactly the same list. What is A, what is P, what is R, and what is T. T we need to calculate. A is final amount is 800. P is initial amount is 500. R is the interest rate 0.06. So write the formula P to the ERT. So we have 800 is equal to 500 e to the power 0.06t. So first we would divide by 500. This cancel out. 800 divided by 500 is 1.6 is equal to e to 0.06t. Now we take log. We can take regular log or ln. I think because we have e, would be more beneficial to use the natural log or ln. You should have ln button on the calculator as well. ln e to the power 0.06t. As before, by the properties of log, this exponent can go in front. So this exponent can go in front. And we have ln 1.6 is equal 0.06t ln e. If you type on calculator, ln e is 1. This ln e is 1. This part is 1. because e to what exponent gives me e is e to the 1. So ln e is 1. Or you can just divide by all the stuff by ln e. So then the last step would be to divide by 0.06, divide by 0.06, this cancel out. So if I type this correctly, I have that t is equal to 7.83 years.